for this honor to present some of our observations on NBP here. I am grateful to CSPC because they have introduced me this drug, Dr. New, Dr. Fung, and I am grateful to be here first time in this province. Although I visited China more than 30 times, I am very grateful to you. The work that I am going to present is our collective work on NBP in several neurodegenerative diseases, and I will show you some of the latest results to you. This is your work done in cooperation with Dr. Feng and Dr. Aruna Hari from Harvard University, Dr. Lefuente from Basque University in Spain, Dr. Morisanu from Romania, Dr. Patnaik from Banaras Hindu University, Dr. Asia from Fayetteville University, and also Dr. Tian, who is one of the leading pioneers of nanowired delivery, and he has US patent. We have funding from Department of Defense, United States Government, European Office of Aerospace Research and Development, Air Force Research of Human Health Factor, and obviously CSPC. Then other organizations, this is Swedish government that is supporting our research. Before, I must say that whatever I am telling to you is my personal opinion, and it has nothing to do with any organizations or government with whom we are working or the grant is given to us. NBP is used in traditional medicine in China since long years, and I am thankful to Dr. New, who told us about this drug for the first time in about 7 years ago, and Dr. Lian Yuan Feng, professor, who introduced me to this wonderful drug to our group. There are several studies showing that NBP is a powerful antioxidant effect and very influential in reducing some of the pathophysiology of Alzheimer's disease, amyotrophic sclerosis, and other neurodegenerative diseases. What I am showing to you in some of the diseases, for example, concussive head injury, Parkinson's disease, and a spinal cord injury, and the results that we have observed in general. This is the chemical structure of NBP, and it is well known. NBP originally is a Chinese celery extract, but now it is synthesized by the company. And professors at Harvard University and Chinese Academy of Medical Sciences showed that the seed extract can prevent some of the Alzheimer's disease pathophysiology and improve memory and cognition. Several clinical studies or trials are going on with NBP in patients with acute ischemic stroke, as well as in different parts of the world, ischemic stroke, and in adult patients, and also the improvement of collateral circulation in some conditions of stroke type of disease. So it means that NBP is well established drug and has profound clinical effects in the hospital. So now there are several studies in animal models showing that NBP improves cognition in mouse model of Alzheimer's disease. And since you know that pathophysiology of Alzheimer's disease and Parkinson's disease is quite similar in nature, we must investigate its full potential of NBP in many kinds of neurodegenerative diseases. Here is an example where this is the treatment with NBP and amyloid beta peptide, astrocytic activation and microglial activations. They are very high in Alzheimer's model of disease, and NBP was significantly able to reduce them all. This is the graphical representation that NBP reduced microglial activation and also astrocytic activation. NBP is also very powerful in reducing traumatic brain injury induced pathophysiology. And traumatic brain injury is one of the important killers in the world. So here an example that NBP was given, and you can see that this is the initial staining. When the traumatic injury and NBP was given, there are many nerve cells were very healthy as compared to the traumatic brain injury here. And also tunnel staining that is showing apoptosis. Here NBP was significantly able to reduce apoptotic changes. These are the graphical representation here. NBP is most powerful here, as you can see. NBP is also quite able to prevent brain edema formation. As a neurologist, you might be knowing that brain edema is one of the lethal causes for patients to die after any kinds of disease, for example, traumatic brain injury. And here, this shows that NBP was significantly reducing brain edema development after traumatic brain injury. Not only that, the functional outcome was also reduced by NBP even on third day. Then there are papers that showing that NBP also prevents damage and reduces mitochondrial dysfunction in MPTP-induced Parkinson's disease in the model. MPTP is a toxic substance and can produce Parkinson's disease-like symptoms given in animal model. This is in cell culture examination, and Parkinson's disease, two things are very important. One thing is alpha-synuclein, and other thing is loss of tyrosine hydroxylase neurons. Here in this example, you can see that NBP is able to reduce the alpha-synuclein in cell culture, showing that it has good effect in Parkinson's disease. One of the interesting clinical trials shows that combination of NBP with umbilical mesenchymal stem cells can prevent carbon monoxide poisoning, and that is very important discovery. Here, this literature shows that NBP ameliorates brain injury-induced pathophysiological changes using cell signaling molecules. And here the example you can see that NBP reduce the brain damage after a stroke. These pictures are self-explanatory. Here is the NBP. It is completely preventing the stroke. Also, the cell changes using hematoxylin and eosine, and especially in hippocampus, you can see that NBP was significantly able to reduce the cell changes in hippocampus and also in cortex. These are the graphical representations. Since we are working with US Air Force research and European aerospace research development, that is military problems, then we must understand the problems of the military when they are put to the combat duties. And traumatic brain injury is quite common to our military personnel, and this is one of the key factors in inducing Alzheimer's disease and even Parkinson's disease. So we have to understand the pathophysiological changes. And when our soldiers return from the war zone, they are showing many psychological symptoms, and that is called post-traumatic stress disorder. I think you are familiar with that. This post-traumatic stress disorder is one of the leading dysfunctional entity in neurological illness. I started this work thanks to Professor Lian Wan Feng. This picture was taken in 2003, and then we started working in collaboration. I am very happy to tell you that we have done some experiments with NBP in concussive head injury, and we found new results. We have used for the first time nanodelivery of NBP to treat neurological diseases, in this case concussive head injury, and we submitted this as innovation to US government because part of our research is funded by US government, and we are surprised to notice that this innovation was accepted in 2014 and telling that this is the first time NBP was nano-delivered for concussive head injury, and we found very good results. I come back to these results later. This was the national innovation in 2018. We have another innovation to our group credit, and this was in 2000 innovation showcase showed that novel therapy to neuroprotection in Parkinson's disease by nano delivery of NBP. So we are very happy because these innovations were really examined in great details by various US government organizations, and it is not a joke to achieve this status. So we wanted to understand that previous laboratories showed that nanowired NBP can induce neuroprotection in concussive head injury. Since head injury is one of the leading factors of inducing Parkinson's disease and Alzheimer's disease, we wanted to study the effect of NBP in Parkinson's disease. Also, the FDA now wants to study the environmental factors that govern various kinds of diseases. Therefore, what other factors like hypertension, diabetes and stroke, or other factors and combination of drugs. So we have used also mesenchymal stem cells together with NBP to see what happens. And we are again very privileged to inform this august audience that in 2019, some of the results with NBP in reducing the pathophysiology of Alzheimer's disease found another innovation accepted by the US government. As you know, that Alzheimer's disease is now not the only questions of aging brain, but due to various factors like traumatic brain injury and other diseases, it can also occur in young populations. Therefore, we should be vigilant to understand or minimize the pathophysiological or cognitive deficits in Alzheimer's disease. As you can see here, that the Alzheimer's disease results in loss of neurons, dilatation of cerebral ventricles, and this is entirely different from mild cognitive dementia. So one must understand the difference between mild cognitive dementia and Alzheimer's disease. This is an example. You can see that in severe cases of Alzheimer's disease, the ventricular dilatation prevails, hippocampus is shrinking, therefore we have several cognitive deficits. This slide shows the deposition of amyloid beta peptide in 4 different conditions. This one case is traumatic brain injury. The second case is Alzheimer's disease. This is the case of traumatic brain injury in Alzheimer's disease. But the most interesting, this D is for post-traumatic stress disorder. And as you can see, that in post-traumatic stress disorder, we have the maximum deposition of amyloid beta peptide. I can show again this picture in another way. This is control. Very few amyloid beta deposition can be seen, but the post-traumatic stress disorder has the most deposition in several parts of the brain. The question is, where amyloid beta peptide is deposited? Is it in whole brain or specific brain areas? That we don't know, but this paper shows that also you can see that frontal, cingulate, occipital and temporal, there are different areas with different densities. But the most important point to be noted here is that post-traumatic stress disorder has the maximum deposition of amyloid beta peptide. And one of the important regions for amyloid beta peptide deposition is microvessels changes. Cerebral capillaries, the seat of blood-brain barrier, they are altered, leading in deposition of amyloid beta peptide. And the main region is oxidative stress, reactive oxygen species. So therefore, these factors are very important. Well, we are only allowed to show some of the results approved by working with the US government. You need permission to show the results, and we have the only permission to show the results here. That you can see there are 4 images, and the one untreated, there are many mislistened neurons were damaged. The area between neurons are wide, means sponginess and edema formation, We have used one enzyme called neurolizing that is also decreased in Alzheimer's disease and traumatic brain injury. So we have exogenously supplemented this neurolizing. We have some neuroprotection. We have given NBP. Of course, this is nano delivery. We have large number of neurons rescued. And when we have combined with neurolizing, we have also a little higher neuroprotection in Alzheimer's disease. Spinal cord injury is another important disease affecting mankind after motor vehicle accidents, gunshot or traumatic injuries. So we wanted to study the effect of NBP in spinal cord conduction. We started our research on spinal cord conduction very early. This is Dr. Erik Stauber. He is so-called father of single fiber EMG recording in Sweden. And we also produced this spinal cord monitoring book from Springer in 1998, telling how spinal cord monitoring is important to understand the pathophysiological changes in the cord. Of course, the spinal cord injury is largely represented by motor vehicle accident. So we have a model of spinal cord injury in which this is untreated. You can see that very clinical symptoms like swelling can be seen, microhemorrhages and edema. There are different drugs given and they can have different level of neuroprotection. It means that this model can be used to understand changes in spinal cord pathophysiology. I learned that this is Electrophysiological Institute, so I am very happy to show some of the electrophysiological data that we have recorded in our laboratory. So we have used spinal cord conduction, we have used epidural electrodes in rostral and caudal by peripheral stimulation. Here on the rostral side, the spinal cord erode potentials show quite nice amplitude, but that is lost completely immediately after injury, and that is still not recovered after 120 minutes, although the latency has increased. On the other hand, the caudal electrodes did not show any loss of amplitude. Why? Because might be there is inhibition by cutting of some neurons. We have shown all these things in this book. It is recently released in July 2019. And what we have shown here, that potentiation of spinal cord conduction by applying nano delivery of NBP on titanium implanted nanomaterials in spinal cord injury. As you can see here, that what we have shown here, that the amplitude loss after injury can be prevented by drugs, both ways. This is a PCPA drug, serotonin synthesis inhibitor. It has reduced the loss of amplitude. But on the other hand, there is another drug, cyproheptadine, that is having adverse effects. What is the point? The point is that early prevention of amplitude by drugs can produce later edema development, and there is tight correlation. So those drugs which can prevent the amplitude reduction have greater neuroprotective efficacy, and NBP is one of them. For example here, that this is the PCPA treated animal, much more neuroprotection than the untreated group, and this is the cyproheptadine, no prevention by the drug. When we have used NBP, we can see that the amplitude loss was prevented at all the time. Here it means that NBP has quite important effect on spinal cord conduction. This is also shown in latency changes. NBP is able to reduce or prevent the latency increase. Latency increase means loss of spinal cord conduction, you know very well. And at the same time, NBP was able to reduce blood-brain barrier permeability to Evans blue and reduce the spinal cord water content. All tests of these electrophysiological findings can be maintained or re-examined at the ultrastructural level. Being a neuropathologist, we always understand the pathophysiological changes. So here you can see untreated, there is expansion of the spinal cord and loss of many neurons. NBP was very able to prevent these structural changes, and at electron microscopic level, untreated groups show myelin vesiculation, damage and edema, and NBP was able to significantly reduce them. This is one of the important discoveries for NBP in spinal cord injury to our knowledge. Our model is very similar to human cases because we are working in Perth and Australia to having human tissues examined in the same way, and you can see that 6-hour spinal cord injury is many liters of albumin showing that our model can be used very similar to the clinical models in humans. Concerning to the concussive head injury, there are 3 different kinds of head injuries: mild, moderate and severe. We are able to produce moderate concussive head injury. That is important to understand the drug effects, and this is our model. 114.6 gram weight is delivered over the skull that can produce 0.224 Newton impact, that is moderate. And just for comparison, we have listed few of the things that after injury any kind, stroke, ischemia, Alzheimer, many endogenous substances are released. Some of them are very harmful and some of them are endogenously very important. So these are the list of certain agents are released after injury. They are trying to have endogenous neuroprotection, and these are showing endogenous neurodestruction. Drugs can balance between them that could lead ultimately to either neurodestruction or neuroprotection. In case of NBP in concussive head injury, these are important points. This is concussive head injury 12 hour, 24 hour. This is Evans fluid leakage, this is iodine leakage, this is brain water, brain swelling and neural injury. What you can see that there is progressive increase of these parameters after 12 and 24 hours. NBP when given in 60 milligram doses was able to significantly reduce all of these factors. Whereas when we have used nanowired delivery of NBP, only 40 milligram was able to even produce much more better neuroprotection than NBP given normal. This slide shows that when we have injury on the right side, there is left side is much more damaged. And this is very well known to neurosurgeons as a counter-co injury. Our model represents this counter-co injury, telling that the uninjured side, the left side, is showing much more damage, brain edema and blood-brain barrier breakdown. When we have used NBP, you can see that all blood-brain barrier, permeability and brain edema were significantly reduced, very near to the control level. And this is the pathological examination. This is left side showing many neurons damaged. Then the right side, NBP was able to significantly reduce, only few neurons are showing distortion, and nanowire delivery of NBP is showing almost complete prevention of brain pathology. Then the question is, what will happen in Parkinson's disease together with brain injury? And these are some of the papers we have presented. I can only tell you that nowadays stem cells are also nanowired and they can have significant neuroprotective effects for a longer time. This is another example. So we have measured some biological parameters in Parkinson's disease, and I am showing you later. You can see that biochemical changes in Parkinson's disease and alpha-synuclein and tau protein measured in cerebrospinal fluid, substantia nigra pars compacta and the striatum. These are most vulnerable areas in Parkinson's disease, and you can see that MPTP alone in mouse model significantly increases all these parameters, alpha-synuclein and tau protein. When we have added traumatic brain injury, it is much more enhanced here, and NBP was significantly able to reduce these parameters in all cases. But adding mesenchymal stem cells, in this case, were further amplified the effect of NBP. These biochemical parameters reduction is correlated well with physiological effects in brain. For example, this is blood-brain barrier permeability to Evans blue, to iodine and neuronal damages. As you can see that both levels in hippocampus CF4, substantia nigra pars compacta and striatum, all these values were significantly enhanced in NPTP as compared to control. Addition of traumatic brain injury has further enhanced these values in all the cases. NBP was significantly able to reduce all these parameters, and adding of mesenchymal stem cells nanowire is further amplified the neuroprotective effect of NBP. The final test is cellular changes that we examine always being a neuropathologist. And here you can see that NBP plus mesenchymal stem cells in Parkinson's disease with brain injury. There are many lively neurons can be seen in the hippocampus that were significantly absent in Parkinson's disease with brain injury or Parkinson's disease alone. And even NBP alone was very significantly helping the neurons to survive in such cases of Parkinson's disease. So we can say that our observations, some of the observations are the first, that's why you get innovation accepted. But NBP has significant effect in Parkinson's disease, and these effects can be amplified using additional mesenchymal stem cells because we have added also traumatic brain injury cases. And this is a large investigation program. We have support from various organizations. I'm not going to take your time, but especially I will mention Swedish Society Foundation, US FDA, and all other organizations I have mentioned before. These are our different grant organizations because it is nanomedicine is very costly experiments. These are our collaborators from various parts of the world. I am from Uppsala University, and I thank you very much for your kind attention.
按照会议的议程，我们稍微变动一下，因为我们的Mr. Sharma 呢，他晚上的航班比较早一点，那么他呢就把讨论环节又往上提一些啊。那么 Mr. Sharma 再我补充介绍一下，可能大家也不是很多不是太非常熟悉。那么Mr. Sharma 教授呢，他是乌普萨拉大学附属医院的外科学的研究部主任，神经生物学教授，神经解剖学的讲师，外科重症监护学、麻醉学、神经系统损伤及修复国际实验中心的主任。那乌普萨拉大学其实是瑞典的一个非常著名的大学，我查了一下，他有8位诺贝尔奖获得者，然后本身诺贝尔也是从那里出来的，所以是全世界一所排名非常靠前的百强大学。那么大家有这个机会呢，我觉得也是非常宝贵的，大家趁这个机会和Mr. Sharma 多沟通交流一下啊。那么现在这个讨论环节呢，按照大致安排，我们交给冯兆辉博士来主持。
Anybody have a question? You can. This is good chance to provide your question. Yeah. Anyone has a question? Yeah.
Hello, welcome to our school. I have a question that in some treatment in the stroke the brain, I think maybe we can use some drugs to. Sorry.
It's okay.
Yes, it's so exciting for me. Yes, I think maybe we can use some drugs, just like hormone, just like electricity to stimulating the